Namaste. This is JVN Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss on the module 2 Big M method, and this Big M method is a part of the course Operation Research under the program of BBA 6th semester and BBA LLB 6th semester of the university. So the today's session of Big M method is a very important method of solution a linear programming problem, which is also known as LPP in the linear programming in the operation research, and this linear programming problem is a model in the operation research subject, operation research course, and it is very important model where just the objective function and the constraints may be in equality form or maybe in equality form are in linear form. So that we can say here the objective function and the constant in the LPP in the linear programming problems will be in the linear form, means in the 1 degree form, and the Big M method is also just a method to solve a linear programming problem where the artificial variables come in the basis. And this is just a supplement method of two-phase method, as all we know that two-phase method is also a method to solve a linear programming problem and in presence of artificial variables. So in the problem of in the method of Big M method, just we will assign the very high negative cost minus m to the artificial variables, and the usual cost for the other variables in the objective functions will be taken, but the artificial variables will be assigned a very high negative cost m, that means minus m will be assigned to the artificial variables. And as all we know that in presence of the artificial variables the objective function cannot be improved. So it means the elimination of artificial variable is required to solve the problem, and therefore just when the artificial variable will be eliminated in the means when it is just get rid of from the basis from the table, then it cannot be again written for the next table, and once it is get rid of, then it is not required to write again, to take again in the basis and or in the table. And just now we have to solve for our table, for our question, by the usual simplex method, and this is a very good method of solving the linear programming problem. While the two-phase method is another method of solving the linear programming problem in the case of the presence of artificial variable, but here the two phases will be used, but in the Big M method the concept of the two phases will not be considered. Here just by the simplex method, by the usual simplex method, the problem will be solved. And to explain this with example, just we take the help of some slides, and here we will just explain with the mathematical concepts and with examples. So we take some slides to explain this topic of Big M method, and Big M method very just with clearance. So we take these slides, and here in the first slide the big M method in the linear programming problem is explained that here, and just we have explained that the big M method is useful for the cases of the presence of artificial variables in the basis, and here the minus M, a very high negative value, will be assigned to the artificial variables, all the artificial variables present in the basis, and the rest variables in the basis, in the objective function will have the same cost as they have in the objective function. And now we just take the next slide, and in this slide we have an example to explain this topic of big M method with the explanation here. So here the question is that the minimize z 4x1 is equal to 4x1 plus 3x2 and subject to the constraints 2x1 plus x2 greater than or equal to 10, minus 3x1 plus 2x2 less than or equal to 6, and x1 plus x2 is greater than or equal to 6, and the non-negative restrictions, the non-negative conditions are x1 greater than or equal to 0 and x2 greater than or equal to 0. So we can see there here the inequations have negative less than or equal to sign and greater than or equal to sign. Both the signs are there. All bi's are 0, are positive. So therefore we have to use the surplus variables, and as well as we have to use the artificial variables to reduce these constraints into equation form, and to make this basis as a unit matrix. So here just we will use the surplus variable x3 and x5, and the slack variable is x4 is also used here in the constraints, and that is the just table. We can see the how the inequations are reducing there. So 2x1 plus x2 minus x3 equal to 10, and minus 3x1 plus 2x2 plus x4 equal to 6, and x1 plus x2 minus x5 equal to 6. So in the first and in the third inequation the basis will not be formed. That's why just we will use the artificial variables a1 and a2 in these equations, and we will assign their cost minus m and minus m to these artificial variables in the table. So initial solution, the initial basic feasible solution can be taken as a1 equal to 10, x4 is equal to 6 and a2 is equal to 6. So that is the initial basic feasible solution which is taken, a1 equal to 10, x4 equal to 6 and a2 equal to 6. So now we have this table where these variables are coming, the artificial variables a1 and a2, and the variable x4 will come there in the basis. So basis costs are CB, minus m, 0 and minus m, and there just these variables are given that like y6, y7 and y4. a1 and a2 have been written as y6 and y7, and the other variable is y4, and now we will just their initial basic feasible solution is taken as 10, 6 and 6. Just we have explained that, and the rest of the table is formed by the usual method, and we can see there the variables, artificial variables are assigned the cost minus m and minus m, and the rest variables will have the same cost as in the actual objective function. And now we can see there in the table, last table, which is the most negative value in the Z star. Z star will represent Zj minus Cj. Z star is equal to Zj minus Cj, and we can see the most negative value is minus 3m plus 4, means y1 is the incoming vector there, and corresponding to this the minimum ratio which is given by xbr upon yrj, the minimum ratio is given by xbr upon yrj, and therefore the minimum ratio is for the variable y6. Variable y6 means the first artificial variable a1. So here this y6 will be the outgoing vector and y1 will be the incoming vector. And now this table is formed where y1 is coming in place of y6. So that is the table, and just this table can be formed by the usual simplex method, and now one more artificial variable is there. This is y7, and it is must to get rid of this artificial variable. So again we will apply the simplex method here, and we can see there now which is the most negative value in this table in Z star. Z star means Zj minus Cj. So that is for the variable y2, and it means the y2 variable will be the incoming variable y2, and corresponding to this the minimum ratio which is given by xbr upon yrj, and that is for the variable y7, and 1 upon 2 is the key element, 1 upon 2, and y7 is the outgoing vector. So y7 will be the outgoing vector, and it will be replaced by just y2 vector. So here just we can see this one. So y2 is obtained, y2 is y7 is replaced by the variable y2, y7 is replaced by y2, and we can see there. Now this is the table, and where this Z star is obtained as like minus 22, 0, 0, 1, 0, 2, and it is just we can see there. So we can see there from this table the Z star value from means Z star means that is given by here like Zj minus Cj. The value of Zj minus Cj is obtained as their all positive values 0, 0 and 1, 0, 2, and here we can see this one all the values will be greater than or equal to 0, and no artificial variable is present in this table. So it means this table will give the final solution, final optimum solution, and the optimum basic feasible solution is given by this. So x1 equal to 4, x2 is equal to 2, and just the maximum Z will be obtained as 22. So maximum Z will be, because here this is given that Z star equal to minus 22, so that is for the minimum, and the maximum Z is equal to 22. Here just Z star value of objective function is minus 22 is there, and it is maximum Z equal to 22. So in this way this question is solved by the Big M method, and this method of Big M method is a very important method for the solution of linear programming problems in presence of artificial variables. And now students are advised to take more problems to solve the linear programming problems by this method, by the Big M method or by the two-phase method, and just prepare also the objective questions and the subjective questions for the examinations and for the competitive examinations. And with this I conclude my today's session. Thank you.